So let's take a second to look at the calculation for experimental error. When we're looking at experimental error, often we want to find what is called the percent error. The percent error calculation is on this slide. It is your actual value, which is some previously determined value. It could be a literature value, or you could be comparing to a previous iteration of the experiment, minus the experimental value, which is your collected data. And this could come in a number of forms. We'll look at an example here in a moment. Divided by the actual value times 100. You'll notice that this calculation is in absolute value. So for our purposes, we're not concerned about whether or not you're too high or too low. Just how far off are you from that accepted or actual value. So let's look at this in context. So this might look familiar to you. So this is a pressure-temperature relationship of a contained volume of gas. Has been plotted on a graph here and then extrapolated to find the x-intercept. The x-intercept, of course, would be where the particles are moving so slowly. Well, actually, the particles have stopped moving, and therefore you have no collisions with the container by the molecules of gas, and so you have zero pressure. At zero pressure, we have our lowest possible temperature, which is not moving, or what we would refer to as absolute zero. So how do we tackle this in terms of the experimental error calculation? So 4% error, we want actual minus experimental over the actual times 100%. Our actual value, absolute zero in degrees Celsius, is going to be negative 273.15. We're going to subtract our experimental value of negative 286 and then divide by negative 273.15 and then times 100%. So the first thing we want to do is that subtraction on the top, and we get 12.85, but we need to recognize that the negative 286 has 3 significant digits, and the estimated digit is in the ones place. And so since this is a subtraction problem, we're going to need to round our temperature for that subtraction to the ones place. And so we're only going to have 2 significant digits in that subtraction. Now, having said that, you want to go ahead and circle or underline or somehow indicate how many significant digits you should have, but don't round off until you get to your final answer. So go ahead and take the 12.85 divided by negative 273.15, but you want that to be rounded to 2 significant digits when you're done. So do the division times 100%, and you should end up with a percent error of 4.7, which is not too shabby. You're only almost 5% off the expected value from a fairly rough graphical analysis of absolute zero.